Welcome back to my online video tutorial series. At the end of this video, you should know how to draw the sectional elevation for a floor plan. In this case, the section is not symmetrical. It doesn't run through the center of the building. It's important. This particular question is a Csec past paper. It is 2005. And I did some work previously on this question. So it says we're to draw to a scale of 1 to 50 the full sectional elevation section AA to include foundation details, floor construction, wall details, roof details, and 3 vertical dimension. The second part asks that we draw the eave detail to show a suitable method for anchoring the roof. All right, so I will be focusing on the first part of this. We will need, the first thing is to peruse the specification, because the specification will tell exactly what type of door, the size of the door that you'll need, etc. And it also gives the footing detail. Like here, we have the roof. Before I get into that, I should explain that sectioning, a full sectioning entails 3 very important components. One, a house is typically, a section is divided into 3 parts. We have the probably I should use a different diagram to explain that. Let me share the screen. New whiteboard. Show all. New share. Oh, not really this. Not quite sure if I wanted this. Mouse. Okay. Not quite sure if I wanted that. New share. Okay, so let me share this. Okay. Okay, so this is a sketch of the solution. And what I was saying before is that building a sectional elevation is divided into 3 parts, the 3 sections. We have the, let me use a line. We have the substructure, which is all of this part here, which is, let me get this thing up and running, annotate. Give me a sec. So we have the substructure, which is the section below ground. Okay, so the substructure. So every building is divided into 3 sections, basically. Here is a substructure. This is section, all of this is below the ground. We have the elevation, which is the section right here. Sorry. And we have the roof. The roof is a part of the elevation as well. Yeah. or we could have the sub-level, which is the foundation, the walls, and the roof, which is basically what this asks for. So everything up here at the top would be the elevation. So the footing detail would be, the foundation detail is everything down here. The wall detail would encompass everything inside here. And the roof detail would be everything up here. So typically, you will realize that for this building, there is no ridge board here. And the main reason for that is that we did not cut across the center of the building. We actually cut into the rafter and into the board, the ply board. So note, for this, we actually cut through a kitchen. So this is basically what we'd see if we were to cut into a typical kitchen. This question did not specifically ask for you to draw this kitchen detail, but we typically draw the kitchen, the layout per se for the kitchen. This is a dining area with 2 windows in that section, and the bedroom with a window. So this is basically how the drawing should look. How do we determine, very important question each person might ask, how do we determine the height from here to here? Very important question. That is done by, say for example, this is the wall. This is the wall outline. And this is my roof overhang. Roof overhang. Roof overhang. So this would be, so this is my roof. I would draw a line. So this is roof overhang. And I would draw a line at the angle given for the pitch. In most cases, this is 30 degrees. So I'll draw that at 30 degrees. Changes from that to that. Draw a line. So draw a line at 30 degrees. That at 30 degrees. Yeah. To get the pitch for the roof. I would then need to go back to where the cutting plane line is. In that case, that means a thicker line and a different color. Let's use green. So if the cutting plane line is here, if you cut the building here, and we are looking in that direction. Yeah, at this point here, at the point where the cutting plane line touches the rafter, you would bring that point up to cut the corresponding rafter. Then you would bring this line across here, and this goes down to that. So the roof is formed right here, formed here. Yeah. So this is basically the outline, the shape for the roof. You could also, so this is basically how it would look. Probably I should draw it at a different location, or you could also draw it this way. You could draw a horizontal line, a line here, which is your start point. Ideally, draw this line the length of this. Yeah. Then draw a 30-degree angle there. This would be 30 degree on the inner angle. Bring this point up. Bring this up. Then join here to there. Let's change the color. Use a thicker line. Join here to there. That to that. This would be section wall plate there. Here. Yeah. And of course, you would offset this to get your rafter thickness here, And for here, We build the rafter and the plyboard, etc., etc. And of course, we'd have our rafters, common rafters and jack rafters here as well. Very important. Yeah. So then we would move this. We would establish a base point here. So here would have been our base point at the outside part of the wall here. That would be our base point. So let me delete this one. Use that different color line. Wait. So to move this to the drawing, you would need to establish your peak points. So here, so what I did, I would match this point here on the roof. So I would sketch this. This can be done from a separate location. Yeah. You could also just draw a line across and get this, but this is basically how you determine the height for this and the angle. Well, the angle would be fixed 30 degrees. You would then copy this and drop this, copy this using here as the base point. Here as the base point, you drag it and drop it right here on the roof to get everything there in place. All right. So that's basically how you would deal with that part. All right. Now, how would I go about drawing this in AutoCAD? Yeah. So the first thing to would be to start a new drawing, set up your layers, your limits, your dimension setting if you're not using a template. And then you would start at the at the left-hand side. All right. So you would start here, you'd engage orthogonal mode. Typically, they'll give you the details or the specification that you need to use. In this case, they told us that we were told that the distance from the finished floor, here up to the ring beam right here is 2,800. So we know that, right? Also, I think they give us the detail. Oh yes, I think they gave us the detail for the different layers. So this would be our screed. That's our screed. This typically is our slab. Screed, slab, hardcore, and below that we find the earth. Of course, I've gone through these before. So this is basically a framework. Here would have been our wall or wall, and our footing detail. Up here is our ring beam and our ring beam and our wall plate. Of course, these rafters would be at the same thickness, but here it would cut off. Yeah. And our common rafters, which are typically placed at 600 millimeters apart on center, if not given. But 600 millimeters is basically the standard that we use. All right. From the finished floor to the top of the window, that is typically 2,100. Yeah, that is basic. So from here to the top of the window is typically 2,100. And here is our lintel. We have our lintel here. And lintels are normally square. They're typically 150 by 150. Yes. And of course, our ring beam is typically 150 by 300. And of course, you would offset that inside to get the stirrup and add those details to it if you're using traditional method. If you are using AutoCAD architecture, all of this would be really, really easy. I should be making a video on how to do your sectioning using AutoCAD architecture. But for now, some schools are using the traditional method, so I still teach using both methods. So I think that's enough for this drawing pretty much. So to get started, you would pretty much start here. You would establish your limits, and you draw one line there. This line to be your finished floor. This line to be your finished floor, and we would offset this. You would offset this line, or we could start here. We could start here, up here. Offset this. So draw a vertical line first. Let me start over. Let me tell you basically how I would recommend that you start this drawing. All right. You could, yeah, okay, let me do that. So for line, this can be done using two methods, and I want to explain to you another method that you could use, which I find very time consuming if you're using traditional method. So first you draw a vertical line, and this line should be long enough to cover the distance for the finished floor to ring beam plus the depth of your foundation. So typically you'd make this roughly 3,000 plus one, probably 4,000 is good. So you draw this, then you could draw a line across here. So this is line for your ring beam. So that would be a start. So you would estimate this line for the distance across the building here. You then offset this down to the distance from the ring beam to the finished floor, which in this case is 2,800. So you have that. You would then start from the finished floor. You then offset downward to get the first layer. You could do it this way, or you could draw the walls first and then offset. It's totally up to you. All right, so I typically draw the walls first. So this is my first wall, outer left wall. I will then offset this 150 plus I think this question asks that you add some plaster on both sides. So this is typically would be 170. So you'd offset that much. Offset that. Then you'd offset. While offsetting, I strongly recommend that you use through. So to activate offset, you would type O, enter, click on this. No, but no, before you click, you would click on through or type T, enter. Let me repeat. To draw the vertical walls and to get these distance across nice and smooth, quick and easy, you would, let me delete this one. You establish a first wall here, right? You're now going to offset this wall as these are all parallel. Yeah, you offset this wall to a distance equivalent to the wall. All right. In this case, typically it's 150. It's typically 150. But in this case, they ask us to, question states that it has plaster on both sides. Yeah. And the external walls should be 150 plus plaster, while the internal walls should be 100 millimeters. So you would offset this to 170. You get that? You would then, for offset, you type O, enter, then you will click through or type T on the command bar, enter. What through does, through allow you to click, move, enter distance, click, move, enter distance. So you go really, really fast. So I'll click this line, the last line, move, type the distance for this, get this line, click, left click, move, enter 150 or 170, whatever the case may be. Click, move, enter the distance for dining, go across, yeah. Click, move, and we go across until we get all of those. So this is basically how you pretty much start this. The next step would be to offset this down. So we would the first layer from the finished floor is a screed. So you'd offset this down by between 25 to 50. to get this right here, offset. Of course, we still use through. You then click down and type 100 millimeters, which is the distance for our slab. So we get our slab distance. Click again and move down to get our hardcore. And the hardcore is 150 typically. So we'd have that. From the top of the hardcore, we would then, well, we would then draw the offset, draw next layer, next set of horizontal line for our footing detail. The depth of foundation is normally taken from the top of the hardcore downward. So yeah, the ground level is normally in line with the hardcore. And here is our hardcore. Our hardcore is here. So we would extend this out there, then offset this down, offset this down to offset this line down to the depth of our foundation. And that ranges from 300 to 1200 millimeters. Of course, we typically don't use 300 millimeters unless they're building on solid rock, solid rock. We typically use 900 to up to 1200 to get this right from here. From that, you would then draw your footing. You draw your footing. What I normally ask my students to do while drawing traditionally is that once you get this, you trim this section. You trim out here, trim here, trim this, trim off this section, trim off here, to get something looking like this. To have this looking like that. So I typically draw my footing and then copy and drop it onto these. So I will draw my footing someplace in the drawing, then copy. So once I trim out the section, I trim all of that, I would be left with something like this. So I would, let's use a different color. So I would trim this off. So I would trim our lines. So I trim, draw a line there. That and that. So after I trim this off, let's erase that. So I trim when I trim this section. So if I should trim here, I could then, this would then give me a nice little square section down here, which helps me to copy and paste this footing onto the drawing. All right, so let's go back to let's go back to line. So I would then copy this here, rectangle. I would then copy this here, and I would use here, I could use either here or here as a base point. So I would click here, use here as a base point, bring it up, and well, let's use the top in this case, and snap it onto this. Snap that onto that to get your footing. All right, that's for that part. Now, as it relates to the eave detail, because remember, for the full section, we need all of this detail down here, everything down here, all these layers. And of course, you will need to trim out this part right here. Here should be trimmed. All of inside here should be trimmed out to look just like this. Very important. You would then need to, we could focus on the roofing section of this. So here, you would need to consider the roofing detail. One thing that you need to know is the overhang, and the overhang was given as 450. And to do that, you would, well, at first I normally draw a line at 30 degrees. I then grab this line and bring it into the drawing. So say this is my, let me change this for a little bit. Let me use a larger diagram. Say this is my my wall, and this is that is my ring beam. I would typically draw the wall in AutoCAD at the location, then left click, then grip the middle and drag it drag it a little space inside here, because you want to ensure that this cuts, it creates a notch. What am I doing? Wrong thing I touched. You want to ensure that the notch is created. So you would then go here. So you have that. So you bring this line in until the notch is created here. Then you trim out this section. No, you offset first. Offset to get the thickness for the rafter. Then you trim out the notch. To get to determine exactly how far this is supposed to go and to establish your overhang, it is not so difficult. You can draw a line here, draw a line here. Let's use a different color. Let's use, say, green. So I would draw a line. Well, I could offset this. I could offset this wall out 450, offset this wall out 450 to have it out here, to have it out here. And then you would trim off the excess out here, trim here, trim to clean it up to look just like this end. And then you would proceed. Then you need to, after the rafter, you need to add your other roofing details. Those other details includes the plyboard, and of course the type of details that you add is relative to the type of roof. Yeah, if it's just simple shingle roof, then you would need to add your plyboard. Above the plyboard, you need to have your underlay, and above the underlay, you'd have your shingle, and that's pretty much it. If it's smaller type of roof, you might need purlin. If it's, for example, zinc roof, you might need to add your purlins, yeah, or your lats, all those good stuff. All right. So that's pretty much that for that. Remember, if you find these videos useful, remember to like, subscribe, and share. You know, our purpose is to share the knowledge, not to keep it for ourselves, but in the right manner. You know, we like to be motivated by the support. So if you are enjoying my videos, please take some time out to like and subscribe. I have a lot more videos that I need to edit and upload. Some videos that you guys will find very, very useful. All right, so help us to pass that 1,000 mark. Okay. Thank you for watching. Again, peace out.